Hey there everyone, welcome back to another video. This is chapter 3 and episode 4 of the 06CHEM20 series, and today we are going to be looking at chapter 3, which is stoichiometry. Now stoichiometry is usually a chapter that scares a lot of students because they fail to understand the basics of it, which I'm hopefully going to try and cover. But let me tell you, watching the video will not be enough. After this video, you have to solve as many stoichiometry questions as you can, because the more questions you solve, the better the understanding of it. Just watch this video just to get the concepts, the formulas. Go and solve the questions to actually get it, because if you don't solve the questions, trust me, your stoichiometry is going to be weak as it was. So without any further ado, let's get started. So it says, state the formula of the elements and compounds stated in the subject content. Okay, so if you have x plus y giving me z plus u, you should be able to state the formulas over here and know which, when the question has mentioned formulas, which one is what. Okay, then define the molecular formula of a compound as the number and type of different atoms in one molecule. Now pay close attention, because we'll come to empirical formula and you'll have to know the difference. So let's say I have C6H12O6. Now you know that this is also the formula for glucose. Okay, so this is the molecular formula for the glucose. It's showing the number and type of different atoms. So number and type of different atoms that are in this glucose, right? Deduce the formula of a simple compound from the relative number of atoms present in a model, blah blah blah. Okay, so basically what it means that maybe in an MCQ or in a theory question, they'll have something like CC or H and blah 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 drawn for you, and you'll basically have to count and write down. So for example, this is not unreal compound. Okay, I've just drawn whatever I could. If I wanted to draw something like this, give it an H here, I can't draw H here. Maybe something H. I don't know if that's even a compound or so, but I'm coming. Okay, so oops, yeah. So if I have H here and H here and H, so yeah, so you have to deduce how many elements and the number of elements I have here. So basically you can see that I have 1C, 2C, 3C and 4C, so it becomes C4, and I have 1 2 3 4 5 6 7 8, so that becomes H8. Now I know you haven't reached there, but this is basically an alkene, which is I think butene or so. So yeah, you'll have to just deduce and get the formula by counting the number of elements over there that are over there. Construct word equations and symbol equations to show how reactants form products, including state symbols. So basically like this, where maybe you'll have to add liquid, solid, aqueous, gas. So this L, this S, this AQ and this S are what we know are called state symbols. Okay, so they're just these four of them that you need to know. Okay, so L for liquid, S for solid, AQ for aqueous and G for gas. Then define the empirical formula of a compound as the simplest whole number ratio. Okay, as the simplest whole number ratio of the different atoms or ions in a compound. Now this, where is it? Yes, just a second, let me choose a random different color. Okay, this C6H12O6 that you have of glucose is presented in its molecular formula. If I were to write the same thing in its empirical formula, I'll have CH2O as its empirical formula, because it's like dividing over here by 6 by 6 by 6 to get the whole number ratio. Okay, now one way to find the molecular formula from the empirical formula is, I think, let me get, so basically you find the molecular formula over here. So the MR times N equals to the molecular formula of the times the molecular formula of this. Wait, okay, I can't remember it right now, but I'll make sure I put it in the comments. Okay, don't worry about that. That's the thing. Once you do more questions, you'll be able to get this formula as well. Okay, deduce the formula of an ionic compound from the so the same thing. Okay, then describe relative atomic mass as the average mass of the isotope. Okay, so as we looked at it in the previous videos, so it is the average mass of an isotope compared to the 1/12 of the mass of an atom of carbon 12. Okay, now you're always going to be comparing anything to the 1/12 of the mass of a carbon 12 atom. Okay, so that's basically average mass of the isotope, your AR, compared to 1/12 of the mass of an carbon 12. Okay, then you have your MR as the sum of the relative atomic masses. Okay, so you have your MR as the sum of the relative atomic masses, and it will be used for ionic compounds. Calculate reacting masses, and simple properties calculation will not involve mole concept. Okay, then we move on to state that the mole, they usually ask you to define this, so be careful here. Let me just go back to this one. That a mole is the unit of amount of substances, and that 1 mole contains 6.02 times 10 power 23 particles. Example: atoms, ions, molecules, formula units, etc. Now this 6.02 times 10 power 23 that you see over here is actually the Avogadro constant. Okay, this is the Avogadro constant. So it's basically like saying 1 dozen of bananas basically means 12 bananas, right? So 1 mole of something basically means 6.02 times 10 power 23, maybe atoms, ions, molecules, or formula units, basically, right? Now we have one formula over here. Mole is mass over mr, okay, or the molar mass. And using this formula alone, you can find the amount of substance, the mass, the molar mass, relative atomic mass, and also the number of particles using the value. So number of particles is basically the mole, the number of moles times the Avogadro constant. Okay, you can find molar mass and then the amount of substance. Okay, use the molar gas volume taken as 24 dm cube at room temperature and pressure in calculations involving gases. Now be very, very careful, because I've made so many mistakes over here. They said calculations involving gases, so you do not use this formula unless gases are not involved, and the formula is mole equals volume of the gas over 24 dm cube. Now if the volume is given in cm cube, what you do is basically the volume in cm cube divided by 1000 to give you the volume in dm cube, right? Calculate stoichiometric reacting limiting reactant volume of gases, blah blah blah, in mole per dm cube and gram per dm cube, including the conversion. So now this part over here is basically something you learn from you're solving the questions, but I can't help you with the conversion over here. Okay, also here state that concentration can be measured in gram per dm cube or mole per dm cube. Now when you're converting from mole per dm cube to gram per dm cube, you multiply by the relative formula mass, or the mr, and when you're dividing, you when you want to convert from gram per dm cube to mole per dm cube, you basically divide by mr. And there's a simple way I remember it. Mole is mass, so I'm just going to write gram per mr. So when I multiply this by mr, this and this cancels, giving me my answer in gram per dm cube. And when I have my answer in gram per dm cube and I want to get it in mole per dm cube, I can divide this by mr to get my mole, because mass over molar mass is mole. So that is one way you can use to remember it. Okay, use experimental data from a titration to calculate the moles of solute or the concentration or volume of a solution. Just do questions, trust me, just do questions and you'll get it. Calculate empirical formula and molecular formula given appropriate data. Calculate percentage yield, percentage composition by mass, and percentage purity giving given appropriate data. Just give me a second, let me get something. Just a second. I'm trying to get the formula, if I can get it over here so that you all can see it. Okay, I can't get it, but I'll write it down for you guys. Okay, so when you want to find the percentage yield, you do the actual yield over theoretical yield, and because it's in percentage, you do times 100. Now if you want to find the percentage purity, you basically do mass of the pure substance, mass of pure, over the total mass times 100. These are the formulas that you need to know over here. Now again, I can't stress this enough. In order to truly understand stoichiometry, do as many questions as you can, and come and comment how whether your stoichiometry improved or not. And I'll see you in